And I'd like to talk about the specific areas and strategies for implementation and offer you some tips on things that we've seen that have gone very well. Elena, did you shift over to G? Excellent, excellent. Okay. I'll start, then I'll be handing it over to Jordan in a couple minutes. I'll start by talking about what's driving the change, why it's focused on refineries, and start talking about some of the key elements. And then Jordan and I will both be talking about implementation strategies and resources. First, the catalyst for change. We already talked about what's the two events that are key drivers for this. And obviously, after 20 years, PSM was originally promulgated in 1992. After 20 years, it's always fair to take a fresh look at things. Paul and I were talking over lunch about another issue that happened 20 years ago this year that probably needs a fresh look at too. All these things need to get looked at over the time. The West Texas event and the Richmond refinery fire were just the catalysts for doing that. It was probably something that has been in the background for a long period of time, and that's just the focal point. What I'd like to do is talk about two key platforms for where these things are coming from. First of all, as I mentioned, there are 3 CSB reports. The first one came out fairly quickly fairly quickly. I was going to say from an agency perspective, it takes a lot of time to get approval on these, but still in 2013, CSB came up with recommendations already for some of the key deficiencies in management systems that they perceived or what could be considered areas for improvement. Additional PHA requirements regarding safeguards effectiveness, inherently safer systems requirements, damage mechanism hazard reviews is what they called it at the time. Coordinating regulatory programs, leading and lagging process safety indicators, and also a multi-agency involvement in California regulatory environment. All these should sound familiar because that's a key fundamental aspect of what's going on right now with the CalARP and also the PSM changes in California. In 2014, the second report came out from the CSB that was focused more on regulatory issues. There was a recommendation for restructuring California PSM regulations. You're seeing the results of that right now. Augmenting the PHA to include hierarchy of hazard control analysis, damage mechanism reviews, and also making sure MOCs trigger a fresh look at inherently safer systems. All those are being brought forth in various fashions in the CalARP Program 4 and Cal PSM 5189.1 documents. Regulatory personnel review, make sure that there's technical competence in the review of those things. PHA audits and inspections by the regulator, workforce participation, making sure information is reported to the public, and also regulator funding were all part of this regulatory report done in 2014. Also in 2014, looking at leading and lagging process safety indicators. You saw that earlier, but this was a different emphasis. And also, again, regulator compensation and funding. In early 2015, early this year, there was the final investigation report. It was really more focused, or at least a key part of that was focused on damage mechanism reviews and mechanical integrity of basic equipment. By that time, the CSB had looked over various API reports and guidelines and addressing specific corrosion mechanisms that had existed at had been part of the Richmond refinery fire initiating event in 2012, looking at various damage mechanisms. So all these different API recommended practices, they took a fresh look and said, well, look, these need to be updated to address these things, and there needs to be better application of them. And I've made a list here. That's also in your presentation materials for your reference. The key focal points from the CSB are, the low silicon carbon steel sensitivity, improvements to terminology, looking at other metallurgy and corrosion mechanisms, and basically bringing this into play in the guidelines and also applying them better at facilities. Other recommendations were with respect to emergency response and also repair of equipment and piping. All these things also came out in the last report from the CSB. Auditing and taking a fresh look at things at specific refineries, having approval process at Chevron for resetting the minimum alert thickness to a lower value, that's alert thickness on piping or equipment. Again, specifically designed to address the sort of things that were perceived as deficiencies that led to or at least contributed to the August 6, 2012 event. All right, so all these CSB recommendations, when you take a look at it, really provide the catalyst or impetus for change, and a lot of those changes are now being manifested in CalARP and the CalARP Program 4 and CalPSM documents. Also, the Interagency Refinery Task Force work together. That's those dozen-plus agencies that get together and are formulating the updates or helping CalOES, CalEPA, and CalOSHA formulate the changes to these programs. And they also put together their own report to look at the CSB recommendations and also a fresh look at other things and recommend the basis for the changes that are being made to the regulations. Again, they focus on inherently safer systems, process safety culture assessments, damage mechanism hazard reviews, root cause analysis, human factors issues, and also make sure that safeguards are effective as part of the process hazard analysis. Other recommendations from the IRTF were annual compliance audits, increased frequency of agency inspections, it should say UPA now, it was CUPA at the time, and also an evaluation of the risk management plan on a triennial basis. Community education and alerts, and also agency enforcement, capacity, and reporting for refineries were also part of the IRTF's outcome that they published and is used as the basis for the CalARP and CalPSM changes. So that is the essence for what drove the changes, and what you're seeing right now in the CalARP Program 4 and CalPSM documents are a reflection of that. And so what I'd like to do is look at each of the individual elements. Before we do that, I'd like to go ahead and identify where things are going. As I mentioned, at the federal level, they're still processing comments, so there's nothing that you need to act on associated with changes to PSM or RMP from the federal level now. Now, the problem is that it's going to be desynchronized with your state programs, but given that the federal requirements are much simpler, that shouldn't cause too many complications. For CalOSHA, CalOSHA did issue on the 24th of September the latest draft of their PSM requirements for petroleum refineries, 5189.1, and the CalARP Program 4, the CalARP document in its entirety was updated with the key changes being Program 4 requirements. That was also done on September 24th. Again, recognizing that even though there are differences, the section numbers are different, some of the elements are subsumed into different categories, specifically DMR. Even though you still see some differences in the state program, a lot of the agencies are working together to try to minimize those differences and at least have the technical essence of it synchronized. I did provide a table of the different section numbers and importances that is provided as part of your presentation package. Again, it's color-coded associated with how much effort you need to spend on it, or at least anticipated effort, and depends on everybody's program, which is different. Yours may be better in some areas or not as good in other areas. The green items are things that you wouldn't expect a lot of effort on. The orange and red are things that you should pay particular attention to, with red especially. The safeguard protection analysis, if you're not doing LOPA, or something else to validate the effectiveness of safeguards, that can have a big impact on what you do for your PHAs. We'll talk more about some tips on how to address that shortly. Damage mechanism reviews, again, there's a lot of ways to do this, but there's also a lot of things that you can do right now to minimize the amount of work that you have to do later. Hierarchy of hazard control analysis, it's the same thing. Looking at inherently safer systems and how to improve the fundamental process at your facility can have a big impact, but especially if you're bringing new systems online right now, doing some work at this point can save a lot of retrofit or rework later. Process safety culture assessment, human factors, and management organizational change, and also the management program itself, also things that could result in a lot of extra effort at your facility, and you want to pay particular attention to. All right, so with that overview, what I want to do is go ahead and turn it over to Jordan, who's going to go start going through some elements. I'll pick up where he leaves off, and then we'll keep proceeding.
As Steve let in, once again, my name is Jordan Schultz. For some of you guys that are just joining us, I guess I also kind of skimmed over my bio. Chemical and biomolecular engineering from the University of Tennessee. I've been working with risk management professionals for about 3 years now. Primarily I do PHA facilitation, but I do also do quite a bit with the upkeep and as well as development of these programs and some compliance auditing as well. Having said that, operating procedures, we discussed this kind of in the common deficiencies. I'm going to be focusing largely on the program 4, what they are really kind of driving towards. Obviously, it's the same as any other CalARP program, develop and implement effective written procedures. However, having said that, they're a lot more specific on things they want. You got to address the same kind of operating procedures as usual, but then they will go ahead and actually explicitly require that, you have to list what are the conditions that merit an emergency shutdown. What are the provisions on the authority? Who can initiate that shutdown? And the assignment of the responsibilities. Instead of it just being a best practice, they're actually going to explicitly require you have gone ahead and delineated this person, instead of it just being kind of covered by your training, now it actually has to be as part of your operating procedure. Emergency operations, only qualified operators may initiate the operations and allow other people into the vicinity. Basically, if you're doing it, close off the area, you've got to shut down and depressurize, isolate whatever you can isolate, and then you can go ahead and start trying to figure it out once everything's brought into a safe condition rather than allowing you potentially to go into a pressurized area. Also, they do leave the provision in there, you can provide alternate procedures, but, you have to be able to defend that they are as safe, if not safer, than going ahead and shut down and depressurizing the entire system. Also, you've got to address operating limits. This is something that's kind of intrinsic in what's already in there. You have your operating limits as part of your PSI, but make sure they're actually on your operating procedures now. You're documenting the consequences of deviation, the steps required. This can all be done pretty effectively via one table, say like a matrix where you go, high pressure defined as blank. What happens if you hit that high pressure? This. Steps required, troubleshoot. Safety and health considerations. This is another thing. This is kind of, once again, part of your PSI, but, what they're basically, the basis of that is that personnel don't always read through the entire CalARP binder. I know this is probably shocking to everyone that's actually involved in this program, but, so what they're wanting to do is operators will look at the operating procedures, especially when they're first starting out. They want to go ahead and say, here's what you need to know about ammonia, hydrocarbons, etc. What PPE do you need? And so that way they know all of this. Safety procedures, unique hazards, etc., etc. And also, what are your safety systems? Okay, you've got your PSVs. What are those set at? What is this alarm set point? So that way everything is all in one document rather than kind of going back and forth between your PHA, your PSI, and your operating procedures. This copy of procedures shall be readily accessible. This is kind of a common practice, but it is explicitly called out. And you guys need to review and certify them, like we talked about earlier, annually, but they also do say as often as necessary. If, let's say, you're doing turnarounds, things like that, obviously you need to kind of look at the way you're doing things. Whenever changes occur, same sort of thing. They just want to make sure that you're reviewing these not just annually, but whenever it's applicable. And develop, implement, and maintain safe work practices. This is explicitly called out as well. Another one that is particularly different, control over entry at hazardous work areas. This is sometimes one that isn't really covered under safe work practices traditionally. Obviously, LOTO, confined space, and opening process equipment always is. But handling, controlling, and stopping leaks, as well as that control over entry into the areas, sometimes isn't always covered. Employee participation. This is already, once again, something that's already in place, but they go ahead and they add quite a bit to it. The written plan shall provide effective participation in operating and maintenance activities, or operating and maintenance employees in the PHA, DMR, once again, we're going alphabet soup on you, HCA, MOC, MOOC, PSCA, Incident Investigation, SPA, and PSSR. Essentially, this is kind of intrinsic in the process, but they're going ahead and calling it out that you really need to make sure that you're bringing people in as much as you can. And not just that, but also making sure that they're involved in the upkeep of that program. They don't really want this to be the refinery manager holds on to that book and only he touches it and he might shoot an email down. He wants, the regulation is looking to get kind of a ground level to the top level involvement in the program. Also, you have access to all the documentation. Even if you do mark it as a trade secret, employees are able to access that information. The major change in the employee participation would be establishing a stop work authority. This came out of the PSM regulations that Steve talked about, the offshore industry. Essentially, it's kind of under the same idea. You know, you can't be in the refineries with the pressures and the temperatures that you're working with. You can't wait to call, you know, the refinery manager or do this. Sometimes you just need to be able to make a immediate judgment, knowing operator experience, and bam, just kick down the system. Also, employees may refuse work based on safety and health concerns. Having said that, there is, you know, you need to make sure you're documenting why you think this is an unsafe condition, and then it's relayed on to management. It's not just you can't get out of doing your operator rounds because you don't feel like doing them because safety. But, you know, once again, you can recommend to the operator in charge. That clear line of authority once again comes in that, hey, you know, this is unsafe, shut it down, and then that operator in charge is able to shut down that system without having to go further up the chain. Also implementing an effective hazard reporting program. Most people already have this in place, but all employees may anonymously report hazards in writing. And then this is pretty common, but this does also put in a 30-day notice period. Once that manager or whomever gets the report receives it, they have to respond in writing why they are doing something or are not doing something regarding that reported hazard. And they also have to go ahead and keep a metric on work refusals, reports of hazards, shutdowns, and actual shutdowns. Basically, keeping metrics to say, hey, you know, look, we have a lot of reported concerns. You know, nothing's happened, but maybe we need to look at what we're doing. Or we're reporting a lot of potential shutdowns, or we actually are shutting down the system due to concerns a lot. We probably need to review something. Management system, once again, this is already in place, but it has changed pretty substantially. Reviewed and updated at least every 3 years. You're developing annual goals. You're writing policies and procedures, tracking and documenting all changes to the program, which would include recommendations. Implement and maintain programs to document process safety performance indicators. I'll talk about that here in a bit. And then also doing an annual report certification containing information on those PSPIs. What does this all mean? They want to make sure that management's much more involved in that safety program. Instead of just being the person that signs the binder, they want to make sure that you're actually having those meetings and that you are actively involved in the upkeep and kind of the overall condition of how your program is going. Once again, the CalARP, this is where they've actually put the stop work authority and hazard reporting that I was talking about earlier. It's just an organizational difference, but there's nothing in the actual process itself that has changed. The PSPIs that I was talking about, this comes out of the CSP's, you know, monitor and analyze process safety indicators. They changed the name a little bit, but essentially what you're trying to do is come up with, and this is a list of common ones that they had already called out in the regulation, pass-through inspections of process piping and components, pass-through inspections of pressure vessels, pass-through recommended action items, seal leak repairs on utility systems and the dates installed, the number of major incidents that occurred in the calendar year. Having said that, they also will request that you go ahead and develop a site-specific list. Personally, I would say, you know, if you're kind of looking into doing something like this, CCPS has process safety metrics, and API has API 754. Yeah, 754. They go ahead and give you a big, broad list of how to develop these kinds of programs, as well as ideas on what you could look into. CalOES also plans to go ahead and put some of these indicators and updates on everything, and then you're reporting to CalOSHA on a monthly basis. With that, I'm going to bring Steve back up. He's going to kind of talk about PHA and some of the items that can kind of be related in there.
Jordan, thank you. What I'd like to do is talk about some of the things that were identified in red on my previous slide. These are things that can have a potentially large impact at your facility, but in a lot of cases, some of the best practices have actually been going fairly well in terms of implementation. A lot of people are doing a good job with some of these things, And we try to also implement best practices as we do work for these various areas, and I'll share some of those best practices with you. What I want to focus on are several of the areas, again, in red, things that can have a potentially big impact. They're all related to the universe of process hazard analysis and mechanical integrity. Should sound really familiar. Those were some of the key criticisms that came out of the CSB's review of the August 6, 2012 accident. First of all, let's talk about PHAs. The PHA sections have been rewritten to make sure that additional areas of the refinery are encompassed by PHAs. So there's less argument about, gee, should I look at this area versus that area? Is it covered or isn't it covered? The PHAs have to address damage mechanism reviews and their recommendations, hierarchy of hazard control analysis and their recommendations, external events, incident investigation findings. A lot of these things are getting wrapped into the PHA. And really, we do, in fact, probably one of our more popular services. I don't know if popular is the right word or not, but most people call us in for doing PHAs. It's something that can be farmed out to an engineering contractor like ourselves, and it's the sort of thing that can really, if it's done properly, can really encompass a lot of the different safety issues that come up at a facility. Also, as part of the PHA, you've got to apply an iterative hierarchy of hazard control analysis method for all PHA recommendations that result from a scenario that identifies the potential for a major incident. So again, they're trying to blend these different areas that revolve around PHA and make them specifically covered as part of a process hazard analysis. Recommendation closure process and timing has been clarified at the state level. We did discuss that as part of Kern County's requirements earlier during the panel discussion. PHAs must be retained for the life of the process, and new PHAs must be completed within 3 years of the promulgation of the new CalARP or Cal-PSM requirements. So there's a specific timeline set forth for making sure a little bit more near-term action for PHA is done for new portions of the process. Actually, new portions of the process and processes that existed but now are required to do PHAs. So what I want to do is talk about safeguard protection analysis. SPA, Jordan mentioned it, it's basically, now it's encompassed in the PHA sections of the new CalARP and Cal-PSM documents rather than being a separate section. The objectives being to verify the effectiveness of safeguards, to make sure you've assessed effectiveness for each failure scenario and make sure the safeguards are independent of the initiating event. Now, for those of you who do a good job with your PHAs, you'll know that these are fundamental tenets of how you do a good PHA. You want to make sure that safeguards are truly independent, that you're not taking credit for something that's really not an independent safeguard that will do a good job controlling the event or mitigating it should an initiating event occur. And you want to make sure they're effective. If they're not effective, why do you list them? Well, I pick up a lot of, we get involved in a lot of revalidations for things that other people have done, and there's a lot of junk out there, to be honest with you. There's a lot of folks who've done a poor job and just randomly list safeguards. A lot of times it's because the facilitator doesn't have a good handle on the process, the petroleum process. And because of that, when they hear somebody on the team yell out a safeguard, it sounds good, they just write it down and they don't really critically challenge the team to make sure that it's actually effective, that it's actually independent. And we'll talk more about that in a few minutes. The regulatory requirements are to evaluate passive, active, or procedural safeguards and use LOPA, layer of protection analysis, or an equally effective method. You also must document the risk reductions achieved by existing safeguards and safeguards recommended during a PHA. Now, again, for those of you who do a good job with your PHAs, this is not a new concept. This is not a lot of new work. A lot of folks who have applied best practices to their PHAs recognize that safeguard protection analysis does not need to be an additional, a very encumbering type of requirement. But if you haven't done a really good job with your PHAs or you've taken a shortcuts, it could mean a lot of additional work. There's a requirement to conduct the PHA and complete the report within 6 months of finishing a PHA, and it can be standalone or a part of the PHA, and you must retain them for the life of the process. Again, some of these things that where you're doing a good job should not be all that much additional work. But there's a perennial challenge when doing PHAs in the first place, and this shows up as part of safeguard protection analysis. It's human nature to blend issues. When you talk to PHA team and you say, well, can this ultimate consequence happen? They'll say, nope, can't happen. You start probing and you ask and challenge the team, and they will eventually say, well, it can't happen because we've got a high-level shutoff. Well, that's a safeguard. So it's really human nature to kind of blend these issues together, and you've got to be really careful to keep them separate. And if you do that, if you apply that as part of a best practice, you're well on your way to doing a good quality safeguard protection analysis. The challenges also are common mode failures. How many of you, when you're having your PHAs done or you do them yourself, are very careful about identifying transmitters as part of the causal event or safeguards? Oh, I was hoping to see more hands. Okay, that's a best practice, and there's also a good reason for it. I wouldn't say one out of 10 times or even 1 out of 100 times, but it's not uncommon that when we start listing the actual transmitters as contributory towards the initiating event, and also separately as transmitters that are required for the functioning of the safeguard, when, oh wow, we've got the same transmitter. All right, whereas a lot of times it's not obvious. In a lot of cases, your PNIDs don't have as accurate indication of the control and protection functions as you'd like. And when you force yourself in the discipline of listing those things, and it doesn't require a lot of extra work, you really pick up potential common mode failures. So these are challenges in that the PNIDs may not be totally accurate. The engineers on your team may not totally understand the interaction between control and protection systems, et cetera. But that's all part of the concept and the objective of SPA. And it's really designed to address a lot of challenges that have existed in the past. Overcrediting operator response reliability. We had some good discussions on human factors earlier today. The need for somebody to be present, able to hear an alarm if that's what they're responding to, able to make a decision or a diagnosis based on the alarm, getting the approvals to make a change, making a change, and for that change to have an effect, all within your process safety time that's necessary for a safeguard to function. A lot of times people don't think that through properly. And a good operator, if they're in the right place and if they get a definitive alarm, will act and prevent the ultimate consequence in most cases. But you really need to drive the team, challenge the team to really think that through. That's a challenge. If you're not careful, if you don't understand the process, if as a facilitator you don't constantly challenge them, ask why. What's the bottom line transmitter for this? Does the operator have enough time? Explain it to me. If you're not constantly challenging that, you may have a list of safeguards that aren't all that effective. That's happened a lot when people haven't done good PHAs, and that's why these SPA requirements are being put out there. So in terms of practical guidance, if you're doing a good job, there's not a lot of work that you're going to have to do for SPA. But to get there, identifying root transmitters for causes and safeguards, it's not a lot of extra work. It goes well on the way to identifying what's been a big deficiency for validating the effectiveness of safeguards. Facilitator training the team on risk ranking. There are some teams, at least every hour and a half, I've got to explain the risk ranking matrix, the fact that you want to look at ultimate consequences, and you want to go ahead and look at the frequency of the event as the likelihood of reaching that ultimate consequence. Try to explain that over and over again, and overcoming this nature to blend the issues and say that it can't happen because I've got this safeguard is very important, and different teams require different levels of handholding on this. Facilitator challenging the team on safeguard effectiveness, availability, and reliability. I was at a facility in California, and it shall remain nameless, where we were looking at a catch tank for one portion of the process, and it was basically it was a knockout drum on the way to the flare system. The knockout drum, this is a very old facility, very old pumps, very old instrumentation, and we were talking about the reliability instrumentation because somebody had yelled it out as a safeguard. So I started challenging them on the reliability. One of the other operators said, well, yeah, about 2 years ago, we hadn't seen any change in the level gauge. It was a sight class on the level bridle. We hadn't seen a change for a long time, so we assumed the tank was empty. What we found out is that it was full of liquid, and that's why we didn't see any interface level, and it had been sitting like that for about a year. Bad instrumentation, pumps didn't work, a whole bunch of stuff, but it's so important to challenge the team in, does this stuff work? Is it tested? How do you verify functionality? That's all part of safeguard effectiveness. One of the things I like to do, and in fact it's a requirement, we try to standardize at risk management professionals on best practices. One of the things that I like to make sure we do is categorize our safeguards as independent protection layers. If you do that, then basically you're well on your way to making sure that you're challenging the safeguards and that they're appropriately effective and that they're independent from other safeguards. Listing transmitters. Sometimes a transmitter can feed multiple safety devices too, so if you list those out, it comes up to the surface and the team can at least make a good risk ranking decision on, is there a potential common mode failure that's important or not. If you've got a whole lot of alarms coming off, is 10 alarms for an operator any better than 5 alarms? Well, listing 10 safeguards out there really doesn't tell you too much. In most cases, you're better off, if you have a bunch of alarms, go ahead and list them as one independent protection layer, one safeguard, and then you don't have somebody thinking that you've got a lot of protection features that really aren't there. Because whether it's 5 alarms or 10 alarms, somebody's got to make a decision and take action. And you know what? Sometimes 10 alarms can be more confusing than 5 alarms in terms of trying to diagnose what's going on and what to do about it. Applying risk graph or LOPA or some sort of technique to get additional insights on the various scenarios. LOPA is actually mentioned in the regulations. If you do it right, do it consistently, it can add about 10 to 20% to your effort, but you get a lot of insights for that. If you find yourself getting dragged down by the quantification, take a second look at what you're doing and see if you can focus your energies a little bit. It doesn't need to be all that complicated. And again, applying them to the high-risk scenarios. If you're applying LOPA on things that are like no, never mind, ho-hum, who really cares if you have an operational upset, maybe you're overdoing it, take a step back and see if you can gear your application towards high-risk scenarios. Other implementation tips, we talked about operator response to alarms. Again, if you're doing best practices and start doing them now as part of your culture at the facility, it's not going to be a lot of effort to verify that you've addressed the requirements when they do come out. Mechanical integrity. All right, there have been some changes in general, and I'll be focusing on DMR. The substantive changes have been minimal. There's not a big discontinuity with current industry best practices. There's some additional specificity on documentation, clarifications on records retention, and also references to RAGAGEP, but not a whole lot of direct requirements other than the areas that were perceived as a problem for the August 6th, 2012 refinery fire. So let's talk about DMRs. Okay, damage mechanism reviews are designed to look at damage mechanisms, mechanical, chemical, physical properties, such that you can degrade materials or have potential problems. There's a requirement to do it doing it prior to PHA and prior to any changes that affect chemistry, metallurgy, or operating limits. There's a timeline set forth on when you need to do that and things that can trigger re-looking at a DMR, re-looking at your system and doing a DMR. There's some specific failure modes that are identified. Obviously, you want to cover those requirements. Go beyond that to look at other requirements that may apply to your specific process. Keep in mind that PSM, CalARP, RMP are all performance-based standards. So you have to decide what depth you need to go to and what you need to look at. But DMR requirements as written specify certain failure mechanisms that are common and focused on refineries. And also DMR reports must be retained for the life of the process. In the lower right-hand corner, I've got a little picture of probability versus consequences and looking at the risk contribution for scenarios. Whether you're looking at a PHA, when you're looking at valves opening and closing, or a DMR, when you're looking at containment of equipment, piping being compromised, those are all scenarios. You're always looking at the likelihood of the scenario and how bad it is. So there's a lot of overlap here. When you're doing DMR, do the same thing. You don't have to be doing extensive effort on things that are relatively inconsequential. So you always want to keep in mind the potential risk contribution. So let's talk about implementation. You talk to individuals, whether it's in the regulatory community or industry, you get a whole lot of different answers about what DMR is going to require. There's a whole range from enhanced contemporary best practices, Best practices right now are doing corrosion studies, having corrosion specialists review them. There's some things in DMR that can be addressed by enhancing those, by specifically having your corrosion specialist involved in your PHA, by having the corrosion studies look at conditions of temperature and pressure which may have exceeded the the specified conditions for the process and maybe shortened equipment life. Those sort of things can be done as part of enhancements to current practices very easily, and that's something really you can do right now. What we like to do when we can convince a client to allow us to do that is we usually recommend a prioritized DMR approach. Basically, for each scenario, make sure that you're sensitive to the material specifications of piping and equipment, and you're looking at the pressure and temperature excursions, either high or low. Low temperature can be a real problem with respect to embrittlement. So you're looking at higher low temperature and pressure and taking a look at the piping and the equipment and comparing it to the specifications. Well, that's something that's very easy to do, requires minimal additional effort, and really cuts at the core of what you're trying to do for DMR. That can be done on a scenario-by-scenario basis. For each node, you can look at material diagrams. You can apply a mini checklist for what sort of things need to be looked at in that portion of the process. Then, for the entire study, you can run a little checklist that looks at how the program, is the program healthy or not? Does the program accommodate corrosion activities, the proper levels of inspection and testing? In those ways, we feel that we can address the majority of the DMR approaches with minimal additional effort for what you're doing right now for PHA. We call that a prioritized DMR approach. That's something you guys can be doing right now as a minimal additional effort for what you're doing. It really fits in well with the PHA, doesn't require a lot of extra effort, and when the DMR requirements come out, you're not blindsided with a lot of additional work. IPHA, for those of you who tap into some of our documentation, we did a paper at the Global Congress on Process Safety this year on the integrated process hazard analysis. We called it IPHA. The idea is that you blend together DMR, PHA, and a little bit more depth and really cover all the essence of all the DMR requirements. It's a little bit extra effort. Doing a complete risk-based assessment on API recommended practice 581 for each piece of equipment in their sensitive units. That's a lot of effort. We tend to recommend the two in the center as things that are practical, can be done pretty easily with minimal additional effort right now that can really address the DMR requirements. Setting out implementation tips. There's a variety of different ways to do this. Don't forget PSM, RMP, CalARP, performance-based standards. You have to decide what you need at your facility. You got to obviously meet regulatory requirements, but you also need to make effective use of facility resources. If you're spending a lot of time and effort addressing nuances that aren't that important, then it's taking resources away from something else. So you really want to keep an overall balance in mind. You also want to minimize any overlap with other safety management system program elements so you're not doing the same work twice. And also, if you're doing some work, take advantage of it. If you've done some really enhanced corrosion studies and you can use that as part of your PHA, great. Go ahead and use it. Again, in terms of suggested approaches, I did review that. Keep sight of your long-term objectives. Do something right now to bump your program up so that you're comfortable that you're getting a good bang for your buck, that you're getting some good value and return on your investment for the analysis work you're doing, but move towards your DMR requirements. Okay, so let's talk about hierarchy of hazard control analysis. For most facilities, this isn't going to change what you're doing very much or make a lot of drive towards major modifications in your process, but it is a requirement and you need to be sensitive to it, and there are things that can potentially come up and bite you in the rear on this. First of all, there's a requirement for ranking of prevention and control measures prioritized by first order safety, basically safer chemicals, things that can prevent an incident in the first place. Second order inherent safety, reducing inventory or reducing the severity or likelihood of the incident, or adding additional independent protection layers, safeguards that can provide some inherent level of safety. There's a requirement to conduct the hierarchy of hazard control analysis for all existing processes, for any PHA recommendations that could have a major incident potential, major changes at the facility, we'll talk more about that in a couple of minutes, major incidents that may have occurred for new processes, and there's been some wording, I don't know if it's in the current September 4th edition, but in previous editions of the PSM and CalARP requirements, there was a requirement for making the hierarchy of hazard control analysis available to the public. And also, if your unified program agency requires it, you also need to do a hierarchy of hazard control analysis. The objective is to reduce risk, of course, and you'll identify and evaluate inherent safety measures such as control techniques or management systems that have been achieved in practice or been recommended for petroleum refinery and related industrial sectors. The approach is an iterative method, and the outcome is the employer is required to select and recommend first and second order inherent safety measures unless you can document that they're infeasible. There's a lot of discussion on that right now, and risk management professionals made some comments to the folks who are writing the CalARP requirements, I'm sorry, the Cal-OSHA requirements with respect to maybe consideration of some benefit cost analysis or some other comparison to risk on these items, because we see this as an area that could be very contentious when you're looking at certain refined processes. There's a requirement for hierarchy of hazard control analysis to be a standalone and to complete the report within 90 days of completion. Let's talk about implementation. First of all, safer systems evaluations. You've seen checklists. You've probably looked at these or applied at your facility. One of the things we like to do is start out when we're doing a PHA for a refinery, really any process, with some synchronization training. As part of the synchronization training, we want to identify what IS inherently safer systems hierarchy of hazard control analysis is all about, and what they should be looking out for. Talk to them and list out the basic considerations such as minimizing materials, substitutions, moderation, or simplifying the systems. And then for each node, we want to go ahead and document that we've looked for inherently safer characteristics. There are checklists out there also to look at the entire process as part of your PHA. So these are things that you can do as part of training, looking at it on a node-by-node basis and documenting that you've evaluated it as a team, and also applying a checklist. So these are things that you can be doing right now. The thing you got to be careful of is timing. If you've got a new process being done at your facility, think about if you find inherently safer system improvements that you can't justify as being infeasible later on when the design's done, process construction completed, and you've started your process. Well, that can be a potentially huge impact in terms of potential shutdowns, potential significant retrofits, a lot of money. So if you're designing a new process, it really makes a lot of sense to implement to the fullest extent the HCA requirements right now to buffer yourself against any significant costs later. So these are things that you can do right now that could potentially avert a significant cost issue later on. And again, as early as possible during plant operation, if you do have changes to make, you want to know about them so you can do them sensibly during turnarounds or whatnot. And again, a lot of the stuff can be done right now, and you want to pick and choose when it makes sense to implement it. There's a lot of references out there. There's various textbooks on inherently safer systems that apply directly to hierarchy of hazard control analysis. There's regulatory guidance. If you look at Contra Costa County's websites and the TCPA website, you'll see specific checklists and guidance for doing HCA. And again, there's checklists out there that can help you out. In most cases, a checklist is going to do a good job as long as you approach it in the spirit of really thinking about it and challenging the team. Have they looked at inherently safer systems? So yeah, with that, I'll turn it over to Jordan, who will address some other elements of the new requirements, and then I'll come back for closure.
Thank you, Steve. All right, I'll start it off, management of organizational change. Obviously, you guys are familiar with MOCs. We've been talking about it a little bit back and forth all day. This is one of those things they've noticed that's been an underlying issue and during a lot of chemical incidents. Essentially, you guys may replace personnel, people leave. People take new jobs, you guys downsize, upsize, whatever you want to look at. You're changing the way that the entire organization is laid out. Maybe you replace that guy that just knew the system front and back, who'd been there for 30 years, with a fresh graduate from college who doesn't know how the system's laid out. Obviously that contributes and could lead up to a hazard. So basically what they want to do is you go ahead and fill it out like it's an MOC procedure. You're looking at the experience level of who you had and then what you're changing it out with, or if you're getting rid of somebody, what's his job role? How's this going to be taken care of? Can they handle these other loads? Making sure the job functions are up to date, and document the following. Results of the analysis, who made that analysis, what factors were considered, did you guys decide to do it or not, and then why? And then basically other things would be necessary actions required to move forward with this change. You say, yeah, you know what, we're going to go ahead and this person's going to leave. Here are the things that we need to find in our next candidate, et cetera, et cetera. Also include a human factors analysis. Okay, let's say you guys are going to cut 4 operators. Obviously, that means some other operators are going to have to work a little bit overtime in the meantime. You need to be looking at, like we've talked about, sleep deprivation. Can they do this? Is there adequate anything? And basically, anyone that's going to be affected by that change needs to be notified prior to making that change. Give them that opportunity from an employee participation standpoint to at least voice their opinion on the matter. Human factors, we've talked about this a little bit. The refinery side of things, they're going ahead and making it a little bit more robust and calling this out as an individual program. Develop, implement, and maintain a written program evaluating staffing levels, complexity and length of time needed to complete tasks, level of training and expertise of the employees. Looking at the HMI and the human system interfaces. Physical challenges of the work environment. It's Bakersfield. I know there's no physical challenges with heat or anything like that out there, but I need to make sure that you guys are going ahead and looking at it. Employee fatigue and shift worker overtime. Once again, this is another one that's been a leading cause for a lot of different issues where people just rack up overtime. Everyone's happy to get paid that extra money. People are happy they're not having to bring on new people, but eventually that can hit you. Communications and understandability and clarity of SOPs and maintenance procedures. Analysis of human factor controls on process equipment and incident investigations, PHAs, DMOCs, SPAs, or HCAs. Looking at it, basically making sure that it's as good as it can be, like airproof mechanisms, automatic system shutdowns for critical operational errors. Also assess human factors in the new SOPs and maintenance procedures, and as well as the existing ones. Revise those procedures accordingly. Make sure that you've assessed 50% within 2 years of the effective date of the regulation, and then the rest of them within that 5-year window or 3 years. Provide training to operations and maintenance personnel, and ensure that people are represented when you're making that human factors program. Incident investigation, you guys know all about this. The big difference being here, they are going to explicitly require you to use root cause analysis. That team member has to know root cause analysis. And then another interesting one that we saw, you must investigate underlying management system causes. Generally, if you dive down deep enough into root cause analysis, it usually is going to lead you there anyways, or at least as a partial reasoning why. But they want to make sure that you are explicitly, the people that are making this decision have gone ahead and said, hey, look, this is something we see that we did wrong from an organizational level, rather than just saying, oh, hey, the ladder was placed wrong. Review results of the HCA and the DMR as part of the incident investigation. Basically, if something happens, go ahead and review all that stuff that Steve's been talking about. Hey, maybe we had a wrong assumption here. We said that we were okay with the risk, but obviously something happened. What was it that happened? Where did we go wrong? So then they want you to go ahead and pull back, revise as necessary, make recommendations. The timeline's the same as the usual. Within 48 hours, you have to assemble the team and initiate. You have to make an initial report within 90 days. Note that's not the final report, that's 6 months, but you need to be making forward progress and noticeable progress instead of just waiting and kind of pushing it back. Process safety culture assessment, we kind of were talking about this a little bit right before lunch, but some people have joined us, and we also kind of talked at a little bit of a different level about this. The program should address encouraging the reporting of safety concerns. Once again, that kind of comes in with what we talked about earlier. You need to be able to have a good hazard reporting system. You should be able to anonymously report anything you see wrong, and you shouldn't be held accountable for it. Rewards don't deter reporting safety concerns. Safety isn't compromised by production. Every level of that organization should be on board with any process safety leadership and include that human factors into all of the PSM elements. Your PSCA program should include methods used to assess the PSC, conclusions from the PSCA, why did you come to those conclusions, recommendations, and an action plan to follow how you are going to close those out. And within 90 days of starting that assessment, or finishing the assessment rather, you have to go ahead and get a final report which has to be signed off by the refinery manager. New regulatory updates, we'll talk about implementation. There's a little bit I would like to note on that later, but new regulatory updates from OSHA, almost everyone I can see, quite a few familiar faces from earlier, but we'll go ahead and talk about it one more time. Ragged gap enforcement, recognized and generally accepted good engineering practices. OSHA wants to go ahead and give you a little bit more guidance on what they want to go ahead and say that things are ragged gap. Usually when I'm auditing programs, people will just say, oh yeah, the system is designed, operated, maintained in line with best industry practice or some sort of canned wording like that. But there's no documentation or there's no evidence to show that is happening in line with industry best practices. The retail exemption, from an oil and gas standpoint, this isn't nearly as big of a deal as it was earlier today in kind of more general industry. But if the facility doesn't fall under SIC codes of 44 or 45, it's no longer eligible for that retail exemption. Essentially, a lot of people were saying from, let's say, fertilizers. They were saying the farmer was the end user. So we are actually just a retail facility, and thus we aren't PSM covered. So there's a lot of Program 2 anhydrous ammonia, or Program 2 fertilizer facilities that have 200,000-300,000 gallons of aqua ammonia. Kind of also talking about aqua ammonia, the cover concentration, use the EPA's 1% policy rather than the commercial grade that initially is currently being used. Aqua ammonia doesn't fall under this, so don't worry quite yet. What they're talking about there is the chemicals that aren't already covered by a specified percentage. Usually they were saying commercial grade, but they started realizing that's a very difficult way to enforce from what commercial grade means, essentially. And they are supposedly coming out with more interpretation letters. Since we are talking about PSM, essentially all of these came from the OSHA RFI that they released about the updates to PSM. So it's, I would say it's pretty reasonable to assume that, one, these are items that they are looking and planning on going forward with in the new PSM that's coming out, and two, any enforcement or interpretation letters that might be coming out later. Those probably also are going to be coming from that OSHA RFI topic list, and those mean that they are some of the things they want to move forward with. From the oil and gas side, there's obviously quite a few of those that could end up of interest. Just as a brief sidebar from OSHA's RFI, covering oil and gas well drilling and services, oil and gas production facilities, atmospheric tank exemptions. Those are just to name a few. Those are off the PSM RFI, not necessarily whether they're going to be in enforcement letters, but I just thought I'd go ahead and have a quick refresher on that. From California, they had Senate Bill 612. The UPA has a general duty clause. Well, they will if this bill moves forward as it's expected. Changing the mapping requirements from jurisdiction to jurisdiction, and also underground and above ground storage tank programs, spill prevention and countermeasures, and hazardous waste. The bill is right there. It covers quite a few things. I just wanted to give a quick brief overview on that. And with that, I'll bring Steve back up to talk about kind of the general implementations and strategies and resources.
Jordan, thank you. All right, so I'd like to close. First of all, I hope everybody got some takeaways. for some tips on getting this stuff done effectively. Thinking ahead, not letting it hit you in the back at the last minute. It's really important for all this stuff. So what I want to do is go ahead and talk about general implementation strategies and some resources that are out there. First of all, what's going on right now, you need to be a little sensitive to the fact that not everything's quite yet synchronized. The CalARP, Program 4, and Cal PSM 5189.1, they've taken a lot of steps to make them synchronized and get them very close. There still are some differences. You need to be sensitive to that and double check what you're doing against the specific requirements. And for a period of time, there will be some differences between the state requirements and federal. I would look, just as in the 1980s, RMPP eventually evolved to CalARP, CalARP being relatively synchronized with the federal RMP programs except for threshold quantities and some other nuances. I'd look to see the federal programs and state programs eventually moving towards synchronization and working towards the same objectives. But for a period of time after 2016, there will be some desynchronization. But for the most part, between federal and state programs, so the state programs are going to be relatively well coordinated. There are some resources out there. Don't chase your tails on this. There's a lot of books, publications. We've done a lot of publications at the Global Congress on Process Safety. We do a lot of webinars. A lot of those are information readily out there, in most cases free, on how to handle all these various new elements and do them effectively at your plant site. There's help out there. Go ahead and get it. Most of the stuff, at least the stuff that we post on our webinars, it's all free. A lot of the papers at GCPS are very, very useful for addressing a lot of these new elements. And even if it goes down to the very detailed DMR items, we did do a paper like that at the Global Congress on Process Safety and a specific webinar. All that stuff's available. I provided you with the link before, and it's also at the bottom of your screen here. So there are resources out there for handling these things. Just be aware of where you're at right now. The California agencies have taken a fresh look at these programs. California is moving ahead with this. The federal agencies are in the process of looking at them, looking at these programs, and probably looking at what California does too. The current focus is California and for petroleum refineries. However, don't stop there and don't ignore what else could be going on. If you're part of a large oil and gas company and for whatever reason, for regulatory requirements or because you're doing something proactively in California, you ought to be able to explain why that if it's important to do for California, it's not being done elsewhere at your other assets, maybe in other parts of the country. There's a potential for these becoming best practices that can be expanded to other highly hazardous facilities in California or outside California, even for other petroleum facilities, petroleum refineries, or even non-refineries. So you need to be aware of this even if you're not directly involved or these aren't direct requirements for you right now, or that will be at the end of 2016 for California petroleum refineries. Again, as I mentioned, CalARP and Cal PSM are a lot of improvements have been made to harmonize those two and synchronize them. There's going to be more long-term movement towards that. And we try to offer some tips. There are easy things that you can do, well, relatively easy things that you can do right now. That's why I put it in quotes, that you can do right now to make progress so that when these things are promulgated, you're not shortchanged on resources or time in terms of getting things done. The little figure in terms of the tiger by the tail, it is a potential tiger by the tail. Don't let the teeth get you. There's been recommendations from regulators, and also it makes sense if there's something that's important to do that's a high value item or is easy to do as part of an extension of your current activities, now is a good time to do it because you're going to have tighter resources and a schedule for completion at a later time. And again, some of these elements, as I mentioned before, for hierarchy of hazard control analysis are best done as early as possible during the design phase. So if you're making any changes at your facility, doing that now, doing your inherently safer systems analysis / HCA for your new process can save a lot of pain and suffering later on if there's something fundamental that needs to be changed that could be a lot of money later but minimal cost now. So you want to carefully monitor these modernization programs. If you're responsible for your facility, focus on the long term. Chart the course of your programs at your facility and make sure that you develop a strategy for effective implementation. Don't play ostrich. This isn't going. You're not going to close your eyes and this stuff isn't going away. The fact that it's been documented, it is coming up. There's a specific schedule in place. I don't see major changes coming forth for a lot of these requirements. Senia, with that, I did have a space for questions, but probably it'll be more effective to raise questions on some of these new requirements as part of our panel discussion after the next speaker, Kevin Beam and Paul Penn, after him are finished, and we do our closeout for today.